Hello everyone. Today we will discuss about pharmacokinetics. In this topic, we will discuss what is the meaning of pharmacokinetics, why there is need to study, or what is the importance of this pharmacokinetic, what are the stages involved in the study of pharmacokinetics. Then we will discuss some pharmacokinetic parameters based upon the pharmacokinetic study and the methods to analyze the pharmacokinetic parameters. The therapeutic response of a drug depends upon three phases. After administration of drug has to pass into three phases. First phase, that is a pharmaceutical phase, second one pharmacokinetic phase, and third one pharmacodynamic phase. In pharmaceutical phase, it is considered as the drug is released from the drug product. In pharmacokinetic phase, it studies the plasma concentration with respect to time. And pharmacodynamic phase, it is a study the relation between the drug concentration at site and therapeutic response produced by the drug. Now, the term pharmacokinetics, actually it is consists of two words, that is pharmaco and kinetics. It is coming from two Greek words, pharmako, that is come from the word pharmakon, while kinetics, that is word from the kinetikos. In Greek, pharmakon means drug and pharmatikos means moving. So we can say pharmacokinetic is a study of movement of drug into, around and out of the body. Generally we ADME, that is absorption, distribution, metabolism and excretion of a drug. Pharmacokinetic, as we said earlier, it is study of kinetic of drug. Kinetics means it is a rate of process, that is study of rate of process. Rate we can define the change in velocity or speed in the relation to time, while process, various processes involved. Once a drug is administered, it get absorbed, it get distributed and it get eliminated out of the body. Elimination maybe takes place by two processes, that is process of metabolism and process of excretion. Gibaldi and Per, pharmacokinetic is a study of time course of drug and metabolite level in different fluids, tissues and excreta of the body, and of the mathematical relationships required to develop models to interpret such data. To study pharmacokinetics, first one, to predict dose and dosing frequency. By using pharmacokinetic parameters, we can determine the dose required to produce desired therapeutic effect and the dosing frequency to maintain the constant plasma drug level. Then to select suitable drug candidate to achieve desired therapeutic effect. Based upon the pharmacokinetics data of that drug, one can select the drug candidate which is suitable to reach the target tissue and to produce the desired therapeutic effect. Then to select a most suitable route of drug delivery or drug administration. Genetic data, that is the process of absorption or the metabolism or how drug get distributed and how it get excreted. Based upon that, based upon these parameters, the extent to which the drug get metabolized or how the absorption of drug takes place, where drug get distributed, which mechanism is there for excretion of drug. Based upon that, one can select the suitable route of drug delivery. So these are the importance of pharmacokinetic studies. Then this pharmacokinetic studies involve different stages, generalized. First one, dosing, means drug is administered to the volunteer. Then sample is collected, different samples, that is either blood sample or urine sample or saliva sample, and drug or metabolites are analyzed for, and pharmacokinetic data is collected, and that collected data is analyzed by using suitable techniques. Now, actually what happens after administration of drug? Suppose drug is there in a drug product. After administration, drug is released from the drug product. Now, once it reaches to the absorption, it gets absorbed and it reaches to the systemic circulation. Absorption is a process of movement of unchanged drug from the site of application to the systemic circulation. Once it reaches to the systemic circulation, it either undergo distribution or elimination. Elimination involves biotransformation and excretion. Drug distribution, it is a reversible transfer of drug between blood and the extravascular fluid tissues. Biotransformation, it is a chemical alteration of drug inside the living organism, while excretion, it is a reversible transfer of drug or metabolite from internal to external environment, and collectively it is all called as disposition. Now, once drug get distributed to the peripheral tissues or to the target organ, it shows the desired pharmacological effects. We can see here the time course of drug, means drug, if we plot a percent of drug against time, we will get here initially, means at absorption site, if we are considering 100% drug labeled amount, then that is a decrease in the plasma drug at the absorption site. Then second one, that is drug in body, which shows initially increase and then decrease the amount of drug in the body. Third one, that is eliminated metabolites. Metabolites means they are obtained after a biotransformation of drug. So initially the metabolites presents or metabolites are amount and then goes on increasing, then drug excreted through excretory organ. Initially amount of drug is less in the body, so excretion is less. As there is a rise or increase in the amount, excretion goes on increasing. Amount of metabolites in the body, it also shows it is proportionate to the various factors like amount of drug, elimination of metabolites. From clinical point of view, the plasma drug concentration is very important. In amount of drug, the term plasma drug concentration is always used. Why plasma drug concentration? One important thing, the concentration of drug at the site of receptor determines the intensity of drug's effect. But it is very difficult to determine how much concentration of drug is present at the receptor site. That's why we can use the plasma drug concentration, because change in plasma drug concentration reflects the change in drug concentration at the receptor site. So we can study that by using plasma drug concentration time profile, in which the plasma drug concentration on y-axis and time on x-axis. If we plot that, we will get one graph. Initial, it shows the phase of absorption, then the steady state concentration, the peak point is achieved, and then there is again decrease in the plasma drug concentration, that is the post absorption phase, and at last elimination phase. There are levels of plasma drug concentration: maximum safe concentration and minimum effective concentration. Maximum safe concentration, above which that is a toxic level, while below minimum effective concentration, that is a sub-therapeutic level. The concentration range between maximum safe concentration and minimum effective concentration, that called as therapeutic range. So to produce desired therapeutic effect, the drug concentration in the plasma should be lie within this therapeutic range. Now one by one we will see. When the concentration reach to the minimum effective concentration, the drug shows the time at which the plasma drug concentration reaches to the minimum effective concentration, that we call as onset time, and the situation is onset of action. Then the maximum plasma drug concentration achieved, that is called as peak plasma concentration or Cmax, and the time required to achieve this Cmax or peak plasma concentration, that we call as Tmax. And then the time period for which the drug concentration remains above the minimum effective concentration, that is duration of action. And the area under the curve of plasma concentration time profile, that is called as area under curve. And all these parameters, that is AUC, Cmax, Tmax, all have very important role in clinical pharmacokinetics. So these are the references and suggested readings for further studies. Remaining part in our pharmacokinetics part 2 lecture. Thank you.